The periodic table is probably the first thing that comes to mind when chemistry is mentioned, but it is quite daunting to look at. So, in this video, we'll go over some of the common terms regarding the periodic table and some of the trends that the table follows. The periodic table of elements is a table that organizes all known elements by patterns. For each element, we have the element name, along with the element symbol, which abbreviates the element name, such as O for oxygen, or named after Latin, such as Fe for iron. Each element also has an atomic number, which tells us how many protons and electrons an element has, and an atomic mass, which is how heavy an element is compared to hydrogen. To find how many neutrons an element has, we just subtract its mass by its atomic number, which is 8 in the case of oxygen. Each element also has at least one ionic charge, which tells us how many electrons an atom needs to lose or gain to become stable. An oxygen atom has a -2 charge, which means that it must gain 2 electrons to become stable, while a sodium atom has a +1 charge, which means that it must lose 1 electron to become stable. The periodic table is divided into 3 major categories: metals, nonmetals, and metalloids. Metals are great conductors, have high melting points, and are malleable and ductile, meaning that they can easily be made into sheets or wires. Nonmetals are poor conductors, not malleable or ductile, and are usually gases at room temperature. Metalloids are a mix of the two, physically behaving like nonmetals but can be conductive like metals, which are essential for semiconductors. The table has 7 rows or periods and 18 columns or groups. Each period has the same number of electron shells per atom, while each group has the same number of valence electrons and similar properties. Knowing what groups are, there are 4 major groups. We have alkali metals in group 1, except for hydrogen. They are soft, have low boiling points and melting points, and are very reactive, especially to water. In group 2, we have alkaline earth metals, and they're the second most reactive. They also have a low boiling and melting point, but they are great conductors. In group 17, we have halogens, which are highly reactive as well and very toxic. Lastly, in group 18, we have noble gases, which are all unreactive. They are colorless and odorless gases that have a full valence electron. For groups 3 to 11, we have transition metals, which are metals with often multiple ionic charges. In between the transition and metalloids, we have post-transition metals, which are softer, more brittle, and have lower melting points than transition metals. The 2 lines of elements at the bottom are rare earth metals, with the first row being lanthanides and second being actinides. Lanthanides are mostly used in alloys with other metals to strengthen them, while actinides are radioactive and mostly human-made. As mentioned before, the periodic table arranges the elements based on patterns, and there are also some special trends that the table follows. Electronegation is how well an element attracts another element to form bonds by taking electrons. The more top right we go, the more electronegative an element is, with fluoride being the most. This trend is the same as ionization energy, the energy it takes to remove an electron from an atom. The more electronegative an atom is, the harder it is to take an electron away. As we go more bottom left, the atomic radius, or the size of an element, increases, following the same trend. The metallic character of an element also increases. This just means how readily an atom can give away an electron, which is the opposite of electronegativity. And there we have it, another massive dump of terminology, this time regarding the periodic table. Please let me know if I missed something in the comments, and I will try to do some research and answer them. I hope that y'all have learned something interesting today. Thank you for watching, and stay hydrated.